This is the last paper of this 2024 9709/32 May June. Total timings for this paper is 1 hour 50 minutes. And the total marks of this paper is 75. These are the instructions given in the beginning of that paper. And now we are going to start this question number 1. Sketch the graph of y is equal to x minus 2a modulus. We know that this can be drawn with the help of this graph paper there, that when y is equal to 0, then x minus 2a whole modulus is equal to 0, or x minus 2a is equal to 0, or x is equal to 2a, where a is a positive constant there. So we can draw the graph like this, that these are the x and y axis there. Here it is 2a, so the graph will be like this. And when y is 0, then x is equal to 2a, and when x is 0 here, then y is equal to this. So this is the graph of x minus 2a whole modulus for this portion there. Question number B part. Solve this inequality 2x minus 3a less than x minus 2a whole modulus. Now we know that x modulus is basically equal to x square root, and that is equal to plus minus x there. So we can find out this solution. 2x minus 3a is equal to plus, 2x minus 3a is less than plus x minus 2a, or 2x minus 3a is less than x minus 2a. So these are the two options given there. So if it is option A and this is option B, then if we use this option A there, then 2x minus 3a modulus is less than x minus 2a. 2x minus x is less than 3a minus 2a, or x is less than a there. For B option, 2x minus 3a is less than minus x minus 2a. So 2x minus 3a is less than minus x plus 2a, or 2x plus x is less than 2a plus 3a, or 3x is less than 5a, or x is less than 5 over 3a. So that is the second option there. So the answer is will be x less than a, or x less than 5 over 3a. So they are both less than a and less than 5 over 3a. So we have to check out which one is the right and which one is the wrong. So you draw the line there where it is 0, it is a, it is 2a. Let's say it is minus a. You will check it out that it is less than a, and you have to check in between these two and then you have to check after this 2. So you will first find x is less than a. So put x is equal to 0. Then the values of this one is 2x minus 3a is less than modulus x minus 2a. You put x is equal to 0. Minus 3a is less than 0 minus 2a. Minus 3a, modulus of that thing is 2a. So minus 3 is less than 2, which is true there. So it means before less than, it is true. Now you will find out in between x is equal to a and less than 5 over 3a. So let's say a is equal to 1 over 3. 5 over 3 is 1 point. Now let's say x value is equal to 1.5. Then we will use this inequality. 2 into 1.5 minus 3a is less than 1.5 minus 2a. So 3 minus 3a is less than 1.5 minus 2a modulus because it is positive always. So 3 minus 3a is less than 1.5 minus 2a. So 3 minus 1.5 is less than a. So a is greater than what? 1.5. So which is always true there. So this is always true there. So that means now we will check the last part. X is equal to 2. Then it will be equal to 2 into 2 minus 3a modulus is 2 minus 2a. It is 4 minus 3a is less than 2 minus 2a is less than 3a. This a. So a is greater than 2, which is not true there. So the required answer of this inequality is x less than 5 by 3a because it is true for this value of a there. That means for this 0, it is a, it is true. For it is 5 over 3a, it is always true. So which is less than 5 over 3 is always less than a. So that value is less than 5 over 3. Now express 6x squared minus 9x minus 16 over 2x squared minus 5x minus 12 in the partial fraction. Since it is having this highest power 2 there and this is having highest power 2 there, so it is known as to be called improper fraction. So first we will solve it in the proper fraction for that, and we will do 6x squared minus 9x minus 16 divided by 2x squared minus 5x minus 12. So it should be equal to 3 there. 6x squared minus 15x minus 36. So this is positive will become negative, negative will become positive, negative will become positive. They are going to be cancelled out. So 15x minus 9x is 6x, 36 minus 16 is plus 20. So we can write this fraction as 6x squared minus 9x minus 16 over 2x squared minus 5x minus 12 is equal to, this is the quotient there, 3 plus 6x plus 20 over 2x square minus 5x minus 12. Let's say it is equation number 1. Now, this derivative is 2x square minus 5x minus 12. So you can write this thing as 2x square minus 5x minus 12 in the factorized form 24. So 2x square minus 8x plus 3x minus 12. So 2 is common there. 2x, it is x minus 4 plus 3 is common there. It is x minus 4, or it should be equal to x minus 4 into 2x plus 3. So our original fraction is 6x square minus 9x minus 16 over 2x square minus 5x minus 12 is identical to 3 plus 6x plus 20 over x minus 4 into 2x plus 3. Let's say that is equation number 2. Now we'll solve this part separately. For this part 2, 6x plus 20 over x minus 4 into 2x plus 3 is identical to a over x minus 4 plus b over 2x plus 3. Because they are the distinct linear factors, so you are going to divide each by a and b there. So it should be equal to 6x plus 20 is equal to a into 2x plus 3 plus b into x minus 4. And let's say that is equation number 4. Now put x minus 4 equal to 0 or x is equal to 4 for a there. So it should be equal to 6 into 4 plus 20 is equal to a into 4 2s are 8 plus 3 plus b is 0. 6 4s are 20, 4 plus 20, 40. It is 44 is equal to 11a, or a is equal to 4. Put 2x plus 3 is equal to 0. Then x is equal to minus 3 over 2 for b. So it should be equal to 6 into minus 3 over 2 plus 20, a with the 0 and b with the x is minus 3 over 2 minus 4. So it should be equal to minus 9 plus 20 is equal to b into minus 8 minus 3 minus 11 over 2. So it is 11 is equal to b into minus 11 over 2. So b is equal to minus 2. So the whole fraction of this one is f of x is equal to 3 over, because a is value is equal to 4. Sorry. 3 minus 4 over 4 over x minus 4 plus b value is minus 2 over 2x plus 3. 3 a value is positive 4. So 4 over x minus 4 minus 2 over 2x plus 3. Now, the variables x and y satisfy this equation. A power 2 minus 2y minus 1 is equal to b power x minus y, where a and b are constants, show that the graph of this y against x is a straight line. The straight line means that there is a linear equation y is equal to mx plus c there. So this is the formation of this linear equation there. So you are going to find out the values of this in the terms of this a power 2y minus 1 is equal to b power x minus y. So you are going to take the log on both sides because the variables are in power. So when they are in the powers, you always have to take the log. So that is equal to log of a power 2y minus 1 is equal to log of b power x minus y. This will become 2y minus 1 log of a is equal to x minus y log of b. Now we open it. 2y log of a minus log of a is equal to x log of b minus y log of b. Because we are going to convert it in the form of y there. So you will combine these two. 2y log of a plus y log of b is equal to x log of b plus log of a. So here y is common there. So 2 log of a plus b is equal to x log of b plus log of a, or y is equal to log of b over 2 log of a plus b into x plus log of a over 2 log of a plus b. Let's say that is 2. So this y is equal to capital Y. This is m into capital X plus c. So c value is this, m value is this. So that is representing what a straight line for this equation there. Given that a is equal to b power 3, state the values of this straight line in the form of y is equal to px plus q, where p and q are the rational numbers. Since a is equal to b power 3, so you are going to substitute this one as y is equal to log of b over 2 log of a is equal to b3 plus b plus only b or log of b? 2, 2 log of a plus log of b. Y is equal to log of b. So 6 log of b by taking the power to this coefficient plus log of b into x plus 3 log of b over 6 log of b plus log of b. So y is equal to log of b over 7 log of b into x plus 3 log of b over 7 log of b. Log of b and log of b cancel, log of b and log of b cancel. So it should be equal to 1 over 7x plus 3 over 7. Let's say it is 1 and you are going to express it y is equal to px plus q. So p value is equal to 1 over 7 and q value is equal to 3 over 7, which are the rational functions there. The equation, fourth question. The equation of this curve is y e power 2x plus y square e power x is equal to 6. Find the gradient of this curve at the point where y is equal to 1. So first of all, we put y is equal to 1, y e power 2x plus y power e power x is equal to 6. So y is 1 there. So 1 into e power 2x plus 1 square into e power x is equal to 6, or e power 2x plus e power x is equal to 6, or this will become e power 2x plus e power x minus 6 is equal to 0. So let e power x is equal to p, then e power 2x is equal to p square. So it should be equal to p square plus p minus 6 is equal to 0, or p square plus 3p minus 2p minus 6 is equal to 0, or p is common, p plus 3 minus 2 is common, p plus 3 equal to 0, or p plus 3 into p minus 2 is equal to 0. So this implies that p is equal to minus 3 and 2. But p is equal to e power x. Let's say that is equal to minus 3, which is not possible because the log of this is not there, of negative numbers. So p is equal to e of x, that is equal to 2. Then x is equal to log of 2. So we got the value of x, that is equal to log of 2 there. So our point of intersection at that point is log of 2 and the y value is 1. Now you have to find out the gradient of this curve there. Y e power 2x plus y square equal to 6. So by applying the differential equation, y as it is into derivative of this one is 2 e power 2x plus e power 2x as it is into dy by dx plus y square as it is into e of x, derivative is e of x, plus e of x as it is into derivative of this 2y dy by dx, and 6 derivative is equal to 0. So this will become 2y e power 2x plus e of 2x dy by dx plus y square e of x plus 2e of x y dy by dx equal to 0. Now this is dy by dx, this is dy by dx. So you take it on one side. So e power 2x plus 2y e power x dy by dx is equal to minus 2y e power 2x minus y square e power x. So dy by dx is equal to minus 2y e of 2x minus y square e of x over e of 2x plus 2y e of x. But we know that e of x is equal to 2 and y is equal to 1. So that should be equal to minus 2 into 1 into e of x is 2, then e of 2x is 4, minus 1 square is 1 into 2 divided by e power e2x, that is 4 plus 2 into 1 into 2. So that thing is equal to minus 2 minus 8 minus 2 minus 10 divided by 4 plus 4 8, or that thing is equal to minus 5 by 2 is the value of this gradient here. Question number 5, part A. It is given that the equation e power 2x is equal to 5 plus cos of 3x has only one root. Show that the root lies in the interval from points x lies between 0.7 to 0.8. So we can write this thing as f of x is equal to e power 2x minus 5 minus cos of 3x. So f of 0.7 is equal to e power 2 into 0.7 minus 5 minus cos of 3 into 0.7, and that value is what? Minus, so it is negative. So f of other value is 0.8. So e of 2 into 0.8 minus 5 minus cos of 3 into 0.8, and that value is equal to, which is positive. So as f of 0.7 into f of 0.8 is less than 0, so the root lies between 0.7 and 0.8. Show that if x sequence of value of this is 0.7 to 0.8 given by this iterative formula, xn plus 1 is equal to half ln of 5 plus cos of 3xn. Since the root lies between 0.7 and 0.8, so we take the average of these two. So we take the value of x1 as 0.7. Sorry. By removing this subscript, it should be equal to x is equal to 1 over 2 ln of 5 plus cos of 3x. So 2 will be multiplied by this, so that will become 2x is equal to ln of 5 plus cos of 3x. Or if we remove this ln, it should be e power 2x is equal to 5 plus cos of 3x. And that is the thing which we have to show there, that it is converges to this value there. Use this iterative formula to determine the correct to 3 decimal places, give the result of each iteration to 5 decimal places. So x1 we have just calculated it equal to 0.75. So x2 will be equal to half ln of 5 plus cos of 3x1, and x1 is 0.75, and that value is equal to 0.739. X3 will be equal to half ln of 5 plus cos of 3x2, 0.74. X4 will be equal to x5 will be equal to x6 will be equal to, so up till correct to 3 decimal places. So 0.740 is the answer of this, because these 3 digits are the same. Question number 6. The diagram shows the curve y is equal to x e power minus ax, where a is a positive constant and it is maximum point m. Find the exact coordinates of this m. Since it is the m is the turning point of that, where the tangent is going to be equal to 0, and you are going to find out the exact coordinates of this m there. So x and y are there supposed to be calculated there. So y is equal to x into e power minus ax. By applying this product rule, so you can u is x and e, v is eax. So dy by dx will be equal to e power minus ax into x derivative is 1 plus x as it is into e of derivative is minus a into e power minus ax, and that will be equal to 0. Because it is, we are finding the m coordinates where derivative of that thing is equal to 0. So here we can find out e of minus ax as common, 1 minus ax equal to 0. But e power minus ax cannot be equal to 0. So 1 minus ax is equal to 0. So this implies that x is equal to 1 over a there. So when x is equal to 1 over a there, then y will be equal to 1 over a into e power minus a, and x is 1 over a. So that is equal to 1 over a into e power minus 1, and that is equal to 1 over ae. So the points of this m, they are equal to 1 over a and 1 over ae. These are the coordinates of this m. Find the exact value of this interval 0 to 2 by a x into e of minus x into d of x. We know that this is the integration by parts formula there. So you put v is equal to x and du by dx is equal to e power minus ax. So dv by dx is equal to 1 and u is equal to e power minus ax over minus a. So you put these into this integration by parts for this formula there. So it should be equal to 0 to 2 by a x into e power minus ax d of x is equal to u there is equal to minus e of minus ax over minus a into v, that is x minus integration of x derivative is 1 into e of minus x over minus a d of x. The limit is 0 to a by 2 and the limit here is 0 to a by 2, which is equal to minus e of minus ax over a into x. This minus and this minus plus 1 over a, and the integration of this e of ax is e of minus ax over minus a, and the whole limit is 0 to a by 2. Now this will be equal to minus 1 over a e power minus a 2 over a into x is e over 2 over e plus 1 over minus 1 over a square into e of minus a into 2 over a minus, we put the lower limit, it is 0 there, so x is 0, so this whole thing will be equal to 0 minus 1 over a square into e of 0. So that will be equal to minus 1 over a. This a and a cancel out. So e power minus 2 into 2 over a minus 1 over a square. A and a cancel. E power minus 2 minus 1 over a square. E power 0 is 1. It should be equal to minus 2 e power minus 2 over a square minus 1 over a square into e power minus 2 plus 1 over a square. Here e power minus 2 over a square is common. It should be equal to minus 2 minus 1 plus 1 over a square. So that should be equal to minus 3 e power minus 2 over a square plus 1 over a square. So 1 over a square even is common there. So it should be equal to minus 3 e power minus 2 plus 1. Now question number 7. Show that cos 4 theta minus sin 4 theta is equal to cos 2 theta. Since cos of 4 theta minus sin 4 theta is equal to cos of 2 theta, but a square minus b square is equal to a plus b into a minus b, and also cos square theta plus sin square theta is equal to 1. So we use this. So cos square theta whole square minus sin square theta whole square, because we are going to prove this identity. So that thing is equal to cos square theta plus sin square theta into cos square theta minus sin square theta. That will be equal to 1 into cos square theta minus sin square theta. But cos of 2 theta is equal to 2 cos square theta minus 1, or that is equal to cos square theta minus sin square theta, or that is equal to 1 minus 2 sin square theta. But here we are going to use this portion as there is no cos in this minus sin square. We can use it as 1 minus cos square theta. So it should be equal to 2 cos square theta minus 1, and that is equal to cos of 2 theta. That is the right hand side of this expression there. So now you are going to integrate from minus pi by 8 to plus pi by 8 cos of 4 theta minus sine of 4 theta plus 4 sine square theta into cos square theta d theta. But we know that cos 4 theta minus sine 4 theta, we have proved it equal to cos 2 theta. So this will become minus pi by 8 to pi by 8 cos of 2 theta plus this 4 sine square theta cos square theta is written as 2 sine theta cos theta whole square into d theta, or that is minus pi by 8 to plus pi by 8 cos of 2 theta, but this thing is equal to sine of 2 theta whole square. That thing is equal to minus pi by 8 to plus pi by 8 cos of 2 theta plus sine square of that thing, which is equal to 1 minus cos of 4 theta plus 1 over 2, 1 minus cos of 4 theta d theta. So that will be equal to minus pi by 8 to plus pi by 8 cos of 2 theta plus half minus half cos of 4 theta, because sine and cos, they are always integrated with respect to the multiple of theta but not the power of theta there. So it should be equal to now cos 2 theta is derivative is sine 2 theta over 2. Integration of this one is plus half into theta minus half into sine of 4 theta over 4, and the limit is there minus pi by 8 to plus pi by 8. So it should be equal to 1 over 2 sine of 2 into pi by 8 plus half into pi by 8 minus half into 2. 2 into 4 is 8 sine of 4 into pi by 8 minus half into sine of 2 into minus pi by 8 plus half into minus pi by 8 minus 1 over 8 sine of minus 4 pi by 8. This will be equal to half sine of pi by 4 plus half into pi by 8 minus 1 over 8 pi by sine of pi by 2 minus half sine of minus pi by 4 plus half minus pi by 8 minus 1 over 8 sine of minus pi by 2. Since 1 over 8 sine of pi by 4 is 1 over root 2 plus pi by 16 minus sine pi by 2 is 1 minus sine pi by 4 is half into minus 1 over root 2 plus minus pi by 16, and sine minus pi by 2 is 0. So this will be equal to, sorry, sine pi by 2 is minus 1. So it is equal to minus 1 over 8 into minus 1 over root 2. Sorry, minus 1. So it should be equal to 1 over 2 root 2 plus pi by 16 minus 1 over 8 minus 1 over minus minus plus. So plus 1 over 2 root 2 minus minus plus pi by 16, and this minus minus plus and this minus 1 over 8. So our final answer is, it is this plus this. So 1 plus 1, 2 over 2 root 2 2 over 2 root 2 pi by 16, and this pi by 16, 2 pi by 16 minus 1 over 8 minus 1 over 6 minus 1 over 8, 2 over 8. So final answer will be equal to 1 over root 2 plus pi by 8 minus 1 by 4. Stop करिए. Question number 8 now. The points A, B, C have the position vectors. OA is minus 2i plus j plus 4k. OB is 5i plus 2j. And OC is 8i plus 5j minus 3k. Where O is the origin. The line L1 is passing through the points B and C. Find the position vector of this line L1. So L1 is basically equal to R is equal to OB plus T times of BC, because it is passing from the point BC there. So BC will be equal to OC minus OB. And OC is basically equal to 8, 5 minus 3. Minus OB is basically equal to 5, 2, 0. And that thing is equal to 8 minus 5 is 3, 5 minus 2 is 3, and minus 3 minus 0 is minus 3, which you can write it as 1, 1 minus 1, because they are the multiple of 3 there. So you can take common number from that there. So the line L1 is basically equal to R is equal to OB, that is 5, 2, 0 plus T times of 1, 1 and minus 1. So this is the equation of the line through B and C, which is this line L1 there. The line L2 has an equation. R is equal to minus 2, 1, 4 plus S times of, mu times of 3, 1 minus 2. Find the coordinates of the point of intersection of this line L1 and L2. So L1 is given there. R is equal to 5, 2, 0 So you are going to find out the point of intersection of these two lines. So you will coordinate this L2 there, where x is equal to minus 2 plus 3 mu, y is equal to 1 plus mu, and z is equal to 4 minus 2 mu. The line L1 is having x is equal to 5 plus t, y is equal to 2 plus t, and z is equal to minus t there. So you can coordinate of these two. So their z coordinate and their z coordinate is this. So if we compare these z coordinates from this, it should be equal to 4 minus 2 mu is equal to minus t, or 2 mu minus t is equal to 4. Let's say it is equation number 3 there. Then we can calculate x value there. X value is equal to minus 2 plus 3 mu is equal to 5 plus t. So that should be equal to 3 mu minus t is equal to 5 plus 2 is 7. So you put value of t into this part. So it should be equal to 3 mu minus t is basically equal to 2 mu minus 4 is equal to 7. So 3 mu minus 2 mu plus 4 is equal to 7, or mu is equal to 3. So when mu is equal to 3, then t value is equal to minus 4 plus 2 mu minus 4 plus 2 into 3, 6 minus 2 is 2 there. So t value is 2 there, mu is 3 there. Now you can check the z coordinate for this line L2, that is equal to 4 minus 2 mu. So that is 4 minus 2 into mu value is equal to 3. So 4 minus 6 is minus 2. And for this line L1, the z coordinate is basically equal to 2. We are going to calculate the y. So y coordinate will be equal to for this line L2, y coordinate is basically equal to 1 plus mu. 1 plus mu value is equal to 3 there. So it should be equal to 4. For this line L1, the y coordinate is equal to 2 plus t. And t value is equal to 2. So that is 4. So they are the same coordinates. So x, y, z are the same. So it means the point of intersection of this line L1 and L2 are x coordinate is there equal to. So we will put the values of x. In any one value we can put 5 plus t value is equal to 2. So x value is 7. Y value is equal to 2 plus t 4, and z value is minus. So that is 7, 4 minus 2. So the point of intersection of this one is 7, 4 minus 2. This we can write it as 7i plus 4j minus 2k. The point D is on the line L2 is such that AB is equal to BD. Find the position vector of D. Since this line is L2 and whose equation of given there is equal to L2 equation is given there equal to minus 214 plus mu times and D is line on L2. Let's say D is at this point and which is having x, y, z coordinates for this D point there. AB is equal to, now the condition there is AB is equal to BD. AB is equal to BD. So AB length, that is OB minus OA. And that thing is, we have calculated it equal to AB equal to, B के coordinates लिखो, OB के coordinates लिखो, 5 minus OA. So it should be equal to 5 plus 2, 7. 2 minus 1 is 1 minus 4. So AB magnitude is equal to 7 square plus 1 square plus minus 4 square and whole square root. That is equal to 49 plus 1 plus 16. So that is equal to 66 square root. Then BD is equal to OD minus OB. OD is basically equal to minus 2 plus 3 mu, 1 plus mu, 4 minus 2 mu, minus OB is basically equal to 520. So this will become minus 2 minus 5 minus 7 plus 3 mu, 1 plus mu minus 2, mu minus 1 and 4 minus 2 mu. So BD magnitude is basically equal to minus 7 plus 3 mu square plus mu minus 1 square plus 4 minus 3 mu square and whole square root. So AB is equal to BD. So that thing AB magnitude is equal to 66 and that thing is equal to minus 7 plus 3 mu whole square plus mu minus 1 whole square plus 4 minus 3 mu whole square root. Taking square on both sides, so 66 will be equal to 49 minus 2 3s are 6, 42 mu plus 9 mu square plus 1 minus 2 mu plus 16, 6 बचा भी, plus 9 mu, 4 minus, 2 mu. Four minus, so it should be equal to 16 plus 4 twos are 8, 2s are 16. Sixteen, 4 twos are 8, 2s are 16 mu plus 4 mu square. Under root क्या आएगा ना? So 66 is equal to 49 plus 1, 50 minus plus 16. So that is equal to 66 minus 42 mu minus 2 mu minus 44 mu minus 16 mu, that is minus 16 mu. 9 mu square plus mu square, 10 mu square plus 4, 14 mu square. 16 and 16 cancel. So 60 mu is equal to 14 mu. 60 mu is equal to 14 mu square. So 14 mu square minus 16 mu equal to 0. 2 cos common. 7 mu minus 30 is equal to 0. Mu is equal to 0 or mu is equal to 30 by 7. So when mu is equal to 30 by 7, so mu is 0, then the same point will be there as is going to lie on that. So mu is equal to 30 by 7. Then the value of d is equal to minus 2 plus 3 mu. So the points of intersection of this d there is minus 2 plus 3 into 30 by 7 that is equal to minus 14 plus 60 minus 14 plus 60 over 7. This is minus 7 plus 30 over 7. 7 4s are 28 minus 60 over 7. So this should be equal to 3 3s are 90. 76 over 7 minus. So this is the position vector of D there. So we can write down this as 76 over 7i plus 37 over 7j minus 32 over 7k. Or you can even take 1 over 7 as common there, and you can write down this number as it is there. Question number 9. The complex numbers are z and w are going to defined by z is equal to 1 minus iota and w is equal to minus 3 plus square root of 3 iota. Express zw in the form of a plus iota b, where a and b are real constants and exact set form. So ZW. Z is 1 minus iota into minus 3 plus 3 root 3 iota there. Now you just multiply this one. That is minus 3 plus 3 root 3 iota minus 3 iota plus minus plus is minus 3 root 3 iota square, and this minus 3 root 3 iota square. But iota square is equal to minus 1. So this should be equal to minus 1 plus 3 root 3 iota plus 3 root iota plus 3 root 3. This should be equal to minus 3 plus 3 root 3 plus iota 3 plus 3 root 3. So this is the exact form of x plus iota y, where the things are given in the third form there. Express z and w in the form of r e iota theta, where r is greater than 0 and theta lies between minus pi to the pi. Give the exact value of r and theta in the exact cases there. Since z is equal to 1 minus iota, so this implies that it is x plus iota y. So modulus of z is equal to 1 square plus minus 1 square whole square root, that is equal to 2 square root. And theta, which is argument of z, that is tangent inverse of minus 1 over 1, that is tangent inverse of minus 1. So that is equal to minus pi by 4. So z is equal to r into e iota theta. So r is basically equal to square root of 2 into e iota power minus pi by 4. So this is the form of z. Now w is equal to 3 minus 3 plus 3 root 3. So again, modulus of w is equal to minus 3 square plus 3 root 3 square and whole square root, which is equal to 9 plus 9 into 327, that is equal to 36, and that is equal to 6. And theta there is tangent inverse of y over x, so that is equal to 3 root 3 over minus 3. And because this z, if it is x, it is y, it is 1 and minus 1. So here the point is going to lie, and that is why this argument is minus pi by 4. And for this value, it is 3 root 3 minus 3 is this value, and 3 root 3 is this value. So this is the point. So this is the argument of this value there. So it is in the second quadrant. So it should be equal to pi minus pi by 3, or that value is equal to 2 pi by 3. So for this W, R E iota theta. So that R is equal to 6 into E iota, and that is 2 pi by 3. So these are the two different forms of this Z and W there. On this organ diagram, the point representing the W and WZ are A and B respectively. Prove that OAB is an isosceles triangle, isosceles right angle triangle, where O is the origin there. W था 6. On this organ diagram, the points representing W and WZ are represented by A and B respectively. Prove that OAB is an isosceles right angle triangle where O is the origin. So if we represent it on the number line system, this is origin. The point is represented by W is represented by A, and W itself equal to minus 3 and 3 root 3 iota. So this is the position of A that is going to be represented by W, and that is equal to minus 3 and 3 root 3. B is going to be represented by ZW, and ZW is being calculated there as equal to three under root 3 minus 3. Here we have calculated it. 3 plus 3 root 3 or minus 3 plus 3 root 3. This is minus 3 plus 3 root 3 and 3 root 3 plus 3. So that is B there. And we have to show that OAB is an isosceles right angle triangle there. So first we get the length of OA. That is equal to 3 minus 0 square plus 3 root 3 minus 0 square and whole square root. That is equal to 9 plus 27. That is equal to 36. That is equal to 6. Now we find first the vector AB. AB is basically equal to OB minus OA. And that thing is equal to OB is equal to 3 root 3 minus 3 plus iota 3 root 3 plus 3 minus A value is there minus 3 plus iota 3 root 3 plus 3 plus 3 root 3 iota. Huh? 3 minus 3. So it is minus 3 plus 3 root 3 iota. So this should be equal to 3 root 3 minus 3 plus iota 3 root 3 plus 3 iota minus minus plus 3 minus 3 root 3 iota. ये plus 3 root 3 iota minus 3 root 3 iota cancel out. Plus 3 is cancelled out by minus 3. So there should be left there 3 root 3 plus 3 iota. So AB magnitude is equal to 3 root 3 square plus 3 square whole square root, that is equal to 27 plus 9, that is equal to 36, and that is equal to 6. So that means OA is equal to OB. So in a triangle there, when the two sides are equal, then it means it is an isosceles triangle. Now you have to show that it is a right angled triangle there. Now let's say this is the triangle AOB. Up till here, let's say this angle is alpha, and up till here, let's say this angle is beta, and you are finding the angle in between these two, AOB. Which is basically equal to alpha minus beta. But alpha is the argument of W, minus beta is the argument of WZ. So that is going to be equal to argument of W minus argument of W plus argument of Z. So that is equal to argument of Z minus argument of W minus argument of Z. Yeah, again, argument W minus argument W minus this. So this and this, they are going to cancel out. So that is equal to argument of Z. So minus argument of Z basically equal to, we have calculated it equal to minus pi by 4. So this angle is equal to pi by 4. That is angle AOB. So if this angle is pi by 4 and these two sides are equal, so this angle is also equal to pi by 4. We have proved it that they are equal there. So this angle we are going to find out now. So let's say it is x, then x plus pi by 4 plus pi by 4 is equal to pi, or x plus pi by 2 is equal to pi, or x is equal to pi by 2, which means that angle AOB OAB is basically equal to pi by 2, which is a 90-degree angle there. So it shows that it is a right angle triangle there. Using your answer to the part B, prove that tangent inverse of 5 over 12 pi is equal to pi root 3 plus 1 over root 3 minus 1. Since argument of both W and WZ are pi by 4 and 2 pi by 3, so as argument of WZ is equal to argument of W plus argument of Z, which is equal to argument of W is equal to 2 pi by 3 minus pi by 4, and that thing is equal to 12 is the LCM, 8 pi minus 3 pi, that is 5 pi by 12. So 5 pi by 12 is equal to tangent inverse of, so that is WZ is basically equal to 3 root 3 minus 3 and 3 root 3 plus 3. So, so it should be equal to tangent inverse of 3, 3 plus 3 root 3 divided by. So you can take tangent toward this side. It is tangent of 5 pi by 12 is equal to 3 plus 3 root 3 divided by minus 3 plus 3 root 3. You can take 3 common there. 1 plus root 3 over 3 common there minus 1 plus root 3. And that thing is equal to 1 plus root 3 over minus 1 plus root 3. That is tangent of 5 pi by 12, which we have to show. Last question number 10. Y is equal to secant cube theta as 1 over cos cube theta. Show that dy by d theta is equal to 3 sine theta secant 4 theta. Since y is equal to secant cube theta, which is written as 1 over cos cube theta, and now you are going to apply this, the rule of the quotient. So dy by d theta is equal to cos of 6 theta cos cube theta into one derivative is 0 minus 1 as it is 3 cos square theta into cos theta is minus sine theta. So that will become equal to minus 3 plus 3 sine theta into cos square theta over cos 6 theta. So that is equal to 3 sine theta over cos 4 theta. And that is the thing we are going to prove it, that it is equal to 3 sine theta into secant 4 theta, as secant is the reciprocal of cos function there. If the variables now be part, the variables x and y satisfy this equation, x square plus 9 bracket sine theta d theta over dx is equal to x plus 3 cos of 4 theta. It is given that x is equal to 3 when theta is equal to pi by 3. Solve this differential equation to find the exact value of cos of theta when x is equal to 0. Give your answer correct to the 3 significant figures. So it is a differential equation given there. X square plus 9 sine theta d theta by dx is equal to x plus 3 cos of 4 theta. So we are going to separate these variables. So it is d theta there. So it should be equal to sine theta d theta. And here it is cos of 4 theta. And this is the integral sign of this is equal to. It is x plus 3 over x square plus 9 into d of x, and this. This thing is written as sine theta secant 4 theta d theta is equal to x plus 3 over x square plus 9 d of x, or this secant sine theta secant 4 theta derivative is secant cube theta, because secant cube theta derivative is 3 sine theta cos secant 4 theta. So the reverse of that thing is that its integration should be equal to secant cube theta. But there is 3 there. So you multiply it by 3 and you divide it by 3. So it should be equal to 1 over 3 secant cube theta is equal to. This is quadratic, this is linear, so you can write it as x over x square plus 9d of x plus 3 over x square plus 9 d of x. Let's say it is equation number 1. But we know that if derivative is in denominator and numerator is this, then it should be equal to ln of function of that. So you can multiply this by 3, so this by 2, and this is divided by 2 there, because x square derivative is 2x. But this is the second part of this one is 3 over x square plus 9. We know that 1 over x square plus a square d of x is equal to tangent inverse of x over a over 1 over a there. This is the integration of this part there. So you can write this thing is equal to 1 over 3 secant cube theta is equal to 1 over 2 log of x square plus 9 plus 9 is basically equal to 3 square. So you can write it as 1 over 3 tangent inverse of x over 3, and it is basically equal to 3 there. So 3 over 3 tangent inverse of x over 3 plus constant of integration a there, that is equal to this. So this 3 and 3 cancel out, but the functions as the limits there, and that limit is x is equal to 3 and theta is equal to pi by 3. Now you put in this part 1 over 3 into cos of pi by 3 whole square, sorry, whole cube is equal to 1 over 2 log of x is 3 there. So that is equal to 9 plus 9 plus tangent inverse of 3 by 3 plus k as it is there. So it should be equal to 1 over 3 into sine cos of pi by 3 is equal to 1 by 2 is equal to 1 over 2 log of 18 plus tangent inverse of 1 plus k. So it is 2 cube is 8. So 8 over 3 is equal to 1 over 2 log of 8 plus tangent inverse of 1 is pi by 4 plus k there. So k value is basically equal to 8 by 3 minus 1 over 2 ln of 18 minus pi by 4. So you put the value of k into this equation number 1. So 1 over 3 secant cube theta is equal to ln of x square plus 9 plus 8 by 3, 1 by 2, ln of 18 plus minus pi by 4. So this is, so now we put x is equal to 0 for the final solution. So it is 1 over 3 cos of 0 whole cube is equal to 1 over 2 log of 0 plus 9 plus tangent inverse of 0 over 3 plus 8 over 3 minus log of 18 minus pi over 4. Cos of 0 is 1, so 1 power 3 is 3, so it is 1 over 3 half log of 9 plus tangent inverse of 0 is 0 plus 8 over 3 minus 1 over 2 log of 18 minus pi by 4. Or this will become 1 over 3 log of 9 power half plus 8 over 3 minus 1 over 3 log of 18 minus pi by 4. Or log of 3, so it should be equal to 1 over cos cube theta is equal to 3 log of 3 plus 8 minus 3 over 2 log of 18 minus pi by 4. Minus 3 pi by 4. So this value is basically equal to, so this value is equal to 3.29 minus 4 point. This is equal to, so cos cube theta is equal to 1 over 4.6 is equal to 0 point. Then cos theta is equal to cos theta is equal to 0.601 is the answer of this question there. So this is the last part of this question number 10. We have solved it, and we have solved from this all papers from 2010 till 2024 of your A levels for this.